Hello friends, myself Jayvir and today we are going to discuss about Newton's law of viscosity, dynamic viscosity and kinematic viscosity which is related to the properties of the fluid. Semester 4. It is applicable to both the branches whether it is civil or mechanical related to fluid mechanics subject. So the first statement is what is Newton's law of viscosity? Newton's law of viscosity. So Newton's law of viscosity, the equation defines that tau is equals to mu du by dy. So where tau is shear stress, mu is a dynamic viscosity, du is change in velocity, and dy is change in thickness layer or distance from the reference layer of the liquid. So it is distance, nothing but distance or thickness. Sometimes you can say thickness. Stress having a unit of Newton per meter square. Viscosity, dynamic viscosity having a unit of Pascal into second. Du change in velocity having a unit of meter per second and distance having a unit of meter. Let's discuss further. Up to the knowledge of bachelors, I can say you need to remember following graphs. Following graph. Oh, sorry. So this y-axis represented by du, change in velocity, and this x-axis is represented by suppose the distance dy. So such kind of graph is generated which indicates that this is a layer of the fluid. Suppose the liquid having the fluid having following layer. So at the bottom point the velocity is 0. As the distance increases the velocity also gets changed. So what is the velocity over here? U plus du. Okay, as the distance changes, so this is dy and this is du. This particular thing is du. So as distance increases the velocity also gets increases. See the beauty of the engineering. So initially we are discussing about the fluids. Now whenever we are taking the velocity of the fluid, we need to derive it into the number of layers of the fluids. So this is nothing but the application of derivation if you actually understand this philosophy. So this is the derivation part, that if a particular thickness of the fluid is having a velocity of u, then the layer above to it having a velocity of u plus du, and layer below to it having a velocity of u minus du. So based on this particular figure, this law is derived. Also, the dynamic viscosity. Now let's find out the unit of the dynamic viscosity. The dynamic viscosity is nothing but the resistance offered by the bottom layer to the top layer of fluid, of any liquid. So that is called particular dynamic viscosity. And let's talk about the dynamic viscosity unit of the dynamic viscosity. So in order to find out the unit of the dynamic viscosity, we need to create the equation of the dynamic viscosity, and that is nothing but mu is equals to tau dy by du. So what is the unit of the tau? Tau means shear stress, so it is having a unit of Newton per meter square, into what is the unit of velocity, dy, meter distance, and what is the unit of the du, velocity, meter per second. Meter cancel out, so the answer is the second. The denominator of the denominator will goes into the numerator, so the answer will be Newton per meter square into second. So Newton per meter square is nothing but Pascal, because it's a unit of a pressure. So this is Pascal into second. So what is the unit of the dynamic viscosity? One of the unit is Pascal into second, or we can say MKS, unit of the dynamic viscosity. In the one manner, we can say it as a Pascal into second, but let further define it into MKS and CGS unit. So for MKS unit, what do you mean by MKS? M stands for meter, K stands for kg, and S stands for second. So what is the MKS unit? In order to find out the MKS unit, we need to define Newton per meter square into second into meter kg in second. So here meter square is in meter and second is in second, but we need to define Newton in terms of meter kg in second. So how to define it? In order to define Newton into meter kg in second, we need to recall our fundamental, that is second law of Newton. What it states? Force is nothing but mass into acceleration. So force having a unit of Newton. So Newton is equals to kg into meter per second square. So divided by meter square and into second. So 1 meter square is goes out and 1 second will going to cancel out. So what is the final unit in case of MKS? What is the final unit of dynamic viscosity in case of MKS unit? That is kg meter per second. Remember, this particular unit is also equivalent to Pascal into second. So sometime in the data it may be given in terms of Pascal into second, sometimes in the data it may be given in terms of kg into meter per second. Both things are same and both the units are for dynamic viscosity. Perfect. Okay, now let's discuss about the CGS unit. So when we are deriving the CGS unit, the CGS unit stands for C for centimeter, G for grams, and S for second. So let's convert this kg into meter per second into grams, centimeter, and second. So what is the equivalency of kg into gram? 1 kg is equals to 1000 gram. So instead of kg, I am putting 1000 gram. Instead of kg, I am putting 1000 gram. Instead of meter, I am putting here 100 centimeter. And second remains same. Oh, sorry, it's my mistake. Here, denominator having a meter part, so my mistake. So what is the exact unit over here? That is, it is not kg into meter per second. It is kg per meter second. Kg per meter second. Correct? Kg per second and per meter. So both the parts are in denominator. Also, I need to remove this particular part. Okay. So that is 1000 gram instead of kg divided by meter. So 100 centimeter into second. So ultimately it would be 1 to 1 to cancel out. So it is equals to 10 grams per centimeter into second. So 1 mks unit, it means 1 mks unit is equals to 10 cgs unit, correct? Further, if I want to discuss it little bit further, I am writing over here. So what is the mks unit? Pascal into second. So 1 pascal into second is equals to 10 grams per centimeter into second. So that is also called gram per centimeter into second or CGS unit of the dynamic viscosity. It may recall in the terms of 10 poise. It is called poise. So 1 pascal into second or 1 kg per meter second is equals to 10 poise, and that is the unit of the dynamic viscosity. So sometimes the dynamic viscosity or majority time in the example whenever it is given in terms of poise. So now let's discuss about the kinematic viscosity. It is represented by V days. I am representing it V days because capital V is given or allotted for volume, which is having unit meter cube. The small v is allocated for specific volume, which is nothing but inverse of density, having a unit of meter cube per kg. And this is kinematic viscosity, which is represented by V days and having a unit of or equation of V days is equals to mu by rho, where mu is nothing but the dynamic viscosity and rho is nothing but the density. So mu having a unit of, as we can just a minute sir. So mu having a unit of dynamic viscosity it is, and having a unit of kg per meter second, which we have already discussed right now, or it may be termed as pascal into second, and in case of CGS unit it may be termed as poise. And density having a unit of kg per meter cube, correct? So how to get the answer of the kinematic viscosity unit? So it is kg, and denominator goes into the numerator, so into meter cube divided by, this is into the denominator, meter into second, and again kg. So kg goes cancel out, meter 1 meter goes cancel out, so this becomes square. So what is the unit of the kinematic viscosity? That is meter square per second, and this is in terms of mks unit. So what is the CGS unit of the kinematic viscosity? In order to convert CGS, what we need to do? We need to convert into centimeters, grams and seconds. So 1 meter is equal to 100 centimeters. So instead of meter, we can write down 100 centimeters square divided by second. So that is nothing but 10 raised to 4 centimeters square per second. Correct? So 10 raised to 4 centimeters square per second is the unit of the kinematic viscosity in terms of CGS system. So 1 mks is equals to 10 raised to 4 CGS as far as kinematic viscosity is concerned. So V days, we can say for V days, the 1 meter square per second is equals to 10 raised to 4 centimeter square per second, and that is centimeter square per second is termed as stock. So 1 meter square per second is equals to 10 raised to 4 stock. So now we are familiar with the two kind of relationship, that is 1 kg per meter second is equals to 10 poise, which is for dynamic viscosity mu, not mu days, it is mu, and 1 meter square per second, that is 10 raised to 4 stroke, and that is related to kinematic viscosity, which is nothing but V days. I hope you get this particular theory explanation very well, and if you are having a doubt, you can comment it in the comment section. And if you want me to give some suggestions so that I can improve my lectures, you can all, your comments are always welcome. Thank you very much. Have a nice day.